Good evening. Our project is identifying opportunities to integrate the Internet of Things into manufacturing. Our group consists of Jenna Sobolski, Salman Hussain, Darshan Pushparaja, Ansu Cha, Vincent Cost, Lee Cargill, and Marconi Lima.
Have you ever wondered what the Internet of Things is? The Internet of Things is any technology that is integrated into a network for the purpose of connecting and sharing important information. The Internet of Things has been used in many different scenarios, providing improvements, for example, on human health, sustainability, and urban safety.
But what if the Internet of Things were used on production plants to make manufacturers become more competitive? Cisco Systems Incorporated has been seeking to identify areas of improvement within Ontario's process and manufacturing industry. These will contribute to technological advancement using the Internet of Things.
We will be focusing on pharmaceutical, automotive, and food manufacturing operations in Ontario. The video presents ideas and recommendations on how to integrate the Internet of Things into manufacturing processes using information obtained from manufacturing and current research.
The Internet of Things has the potential to innovate Ontario's manufacturing sector by improving inventory and demand monitoring, product quality, production efficiency, equipment maintenance, manufacturing safety, and many others. These allow for Ontario's manufacturers to have a competitive edge in the national and international marketplace. First off, we will talk about how IoT can impact a manufacturing company's monitoring and tracking of inventory. Currently, most companies are facing the problem of inventory data error from using hand calculations and estimation software to track their inventory. In the past 20 years, manufacturers have spent a lot of money and hired numerous employees to attempt to accurately monitor their inventory and demand. Sometimes, in order to feed the peak demand, manufacturers will overstock their inventory. This will increase storage warehouse costs. Because of errors made in counting current inventory or estimating demand, manufacturers have difficulty accurately predicting future supply. Producing more than the demand is a waste of resources, but producing less than demand can lead to costly rush production and customer dissatisfaction. IoT can be used at manufacturing facilities to resolve these issues in inventory management. The first solution is to put a radio frequency identification (RFID) device on every item. This can help track the movement and history of each individual part or item.
By using camera or scanning technologies to read RFID, the inventory and demand data can be calculated more accurately. By analyzing this data, we can predict the future demand and inventory requirements. Since this data was automatically collected by a machine, it can be updated immediately. We can also automatically place a supply order by machines. This could save a lot of time and money for the manufacturer. Another solution is to use a GPS to track items produced at a manufacturing facility. IoT can be used to collect useful data about how long it takes for each item to reach suppliers and customers, how many items are purchased by a particular customer, and locating defective items quickly so they can be easily recalled. By using IoT, managers can check the latest live data anytime they want, and they can use the data to generate reports to view useful demand and inventory supply trends that were not possible before. Quality control is a very valuable process in the manufacturing environment. The main issue with quality control is that most manufacturing plants have humans doing the majority of the work. This leads to a far from perfect result of the number of defective products that are shipped out. The problem is the cost incurred can be around thousands of dollars per defect. Also, shipping defective products can sometimes ruin a company's reputation with its customers. The actual workers that are responsible for quality control processes ensure that there is a consistent color, shape, and weight for the products. Sometimes for food products, they will need to measure the actual temperature of each product that goes through the assembly line. In general, these workers visually look at the products for defects, which can lead to a potential for some defective products shipped out. The implementation of the Internet of Things to quality control manufacturing can ensure that the accuracy of detecting manufacturing defects increases. Laser technology can be implemented which will help identify package defects. Through this technology, thickness, size, and surface contour of the products can be measured accurately. Camera technology can also be implemented. Its use can help us determine the color and the shape of the products. Implementing a machine to measure the temperature of all products would help automate the process. The machine would help with measuring the temperature of the food, especially in the frozen food sector. All of the devices could be connected using the Internet of Things, as this would allow for data collection and analysis.
Using the Internet of Things, we can create a software that is responsible for monitoring and report generation of the data. Using data collection, a manufacturing company will be able to make adjustments to its process by analyzing historic information. A simple scenario would be where several products are failing the temperature check. The software would then alert the part of the assembly line responsible for freezing the food. Another key feature that would exist in this software is the ability to generate one-click reports that help analyze the quality control process. This would help identify any weaknesses in the assembly line by simply observing the data in the report. Another issue determined from the survey responses was that workers were manually collecting the spectrometry measures. This includes data for electricity, natural gas, liquid nitrogen, and other sources. This manual process prevents general managers from receiving live spectrometry measurements. Instead of having a worker monitoring the spectrometry of a manufacturing plant, a dashboard software can be created that calculates the live usage of these measurements based on other inputs. Machine maintenance in manufacturing is a big deal, which is why utilizing IoT technologies in this field can boost a company's performance. In the current state of most manufacturing companies, when a piece of equipment or machinery breaks down, it might take some time for anyone to notice and then even more time to fix the disturbance. The reaction time to fix a machine and the downtime of a machine costs money to a company, as the production process is most likely slowed down or completely stopped. This is an issue that affects the profitability and production of a manufacturing plant. Machines within a manufacturing company will need to be maintained on a regular basis in order to keep them functional and productive. Usually there is a predefined schedule suggested by the manufacturer or the machine itself. The issue with this is that in practice, these maintenance jobs are not always done on time or are done too regularly. This causes waste in terms of maintenance cost and downtime of the production line. Maintenance could negatively affect and interrupt the manufacturing process. Maintaining or fixing this equipment also requires specialized technicians. The issue with machines that undergo breakdowns and maintenance is that they are not productive during that time. Therefore, it is difficult to estimate the overall efficiency of a specific machine. It is hard to determine if a machine yielded a good return on investment by comparing that purchase price to the production of the machine because of the downtime that is not tracked and logged. IoT can have a significant impact towards changing the process of machine maintenance.
In the future, when a machine breaks down, the incident will be automatically reported to the necessary people. A report will be generated with the reasons of the incident. In addition of having this information published automatically, it can be connected to the cloud in order to be able to order the necessary parts to fix and purchase them, as well as assigning someone to fix it as soon as possible. Fixing process can be done by either having someone from the outside of the plant come in and fix it, or if the fix is simple enough, a video conference in the plant can be done. Maintenance will be scheduled automatically and reminders will be sent appropriately. Maintenance can be anticipated based on previous failures data. Connecting every machine's maintenance schedule and anticipated workload can optimize the maintenance schedule. The automated system could defer maintenance if it is determined through data analysis of the historical data that it does not have to be done at a later time. When there is maintenance or breakdowns, a new plan to optimize and continue production will be decided and put into an application automatically based on the information available from the network of connected machines, the supply, the demand, and the available resources. To make sure that a specific machine is performing as expected and to calculate the return on investment, every time there is a downtime for a machine, it will be logged to a database that will automatically generate reports concerning the performance and production of a machine. This will allow managers to determine if a specific piece of equipment was worth the purchase or if another supplier should be selected next time a purchase has to be made.
Another major application of IoT in manufacturing is in machine and human safety. IoT can be used to control, monitor, and report unusual or potentially hazardous equipment activity, streamline safety interlock systems, and protect the safety of employees. An issue with older manufacturing facilities is that many of their equipment systems are not automated, so workers are required to manually operate and control the equipment. This can put the worker and the equipment at risk if the worker forgets a step in their routine procedure, or if they are unaware of upstream equipment problems that would cause their routine activities to damage equipment and products. To prevent this from happening, IoT can be used to improve safety interlock systems and prevent or quickly fix errors that are made by workers. This can be done using sensors to connect people to machines, alerting the control room that there is a problem with a piece of equipment and dispatching the appropriate people to fix it. Sensors can also be used for machine-to-machine communication to allow for automatic and safe shutdown if equipment is malfunctioning.
Another current safety issue in manufacturing is that there is no way for control room personnel and managers to know the location of their floor workers at any given time. If an accident occurs and a worker is unconscious, injured, or is not able to call for help, there will be a large delay before emergency response arrives, which would be too late. IoT can be used to prevent this scenario by having each worker wear a wireless device while they are working in the plant that has sensors to detect body temperature, harmful gas exposure, heart rate, and track location. This could be in the form of a headset, wristband, or a shirt tag. IoT can be used to connect the data collected from the sensors to the control room and emergency response team so that if a person becomes harmed, help can be dispatched immediately to their exact location.
Another issue with safety in manufacturing is that many incidents and near misses occur due to workers not recognizing the hazards while working on site. These incidents include slips, trips, falls, minor injuries from hot or protruding objects, and near misses with equipment that have moving parts. To prevent incidents and near misses, the same wearable IoT device mentioned previously can send alarms or alerts to caution the worker before they interact with hazardous equipment or be in a dangerous area. The device can have sensors that detect and warn the worker of slip and trip hazards and proximity of sharp, protruding, or overhead objects. It can also be connected with plant machinery to alert the worker of equipment that is out of service or running abnormally. The efficiency of a manufacturing plant can be improved in several aspects. These aspects include efficiency in waste management, energy management, accuracy of the work, and productivity of the assets used in the manufacturing plant. Current situation. A lack of machine-to-machine communication through the Internet of Things leads to individual monitoring and maintenance of machines. This can lead to a problem not being noticed earlier on. Furthermore, the productivity of employees decreases if each individual machine needs to be monitored. Furthermore, if the process requires a lot of accuracy, the output can be flawed or ruined if the machines are not calibrated correctly. This can be a case when the machines are not monitored constantly in real time. These problems may arise in food processing plants that require a strict set of instructions to be followed. Certain manufacturing processes require an efficient use and management of supplied resources. This case can apply to many industries such as the automotive industry, pharmaceutical, and food industry. An efficient management of resources is required to keep the costs low and get as much output as the plant can produce with the given resources. In order to achieve this, effective communication needs to be established between different plants. This will allow the company to monitor the flow of resources in different parts of the company. Increasing demand of a product in certain industries require for a higher production. However, in certain industries this may lead to a higher amount of waste being generated. This may prove to be harmful for the environment. For this reason, every country has standards that have to be met by every manufacturing plant if the plant is to remain in business. Furthermore, the public image of a company can get ruined if waste is not monitored. Finally, there are numerous ways in which the productivity of an asset can increase if a more efficient process is required. IoT can offer proper solutions to this problem that are unique to each manufacturing plant. Communication between plants can be improved by two-way digital radios that are connected throughout the industrial network. These can assist in effective and efficient communication of real-time knowledge. Through real-time access to people and information when and where it's needed, employees focus on their work rather than attempts to locate resources. Another solution to the efficiency problem is the creation of an integrated architecture structure which allows the machines to connect and enable monitoring by connecting to a central platform software. By allowing real-time monitoring of the manufacturing process, employees are able to increase accuracy of the process. Furthermore, certain machines can be connected to the internet. For example, feeding the Google weather forecast into your facility's energy management application can allow it to cool the building or heat it up a day in advance.
Finally, we will talk about risks and barriers to introducing Internet of Things technology. When using connected devices, there are concerns for the security of the system. A secure system is a system that is available, guarantees integrity and confidentiality of data. Having a system that has no security can lead to a lot of different new problems for the manufacturing company.
Having all of this new data that connects to every machine in a plant will generate a very large amount of data that has to be stored somewhere. There are a few options to do so. The first solution is to have a local database. However, this could potentially become very large and difficult to manage. A second option would be to use cloud computing. This provides easy management of data. However, the company no longer has complete control and the information has the potential of being lost by the contractor. Some of these solutions might have very difficult technical problems when it comes to implementing them. This could lead to having either over-automated systems that do not adapt to the reality of each plant, or to incomplete systems that promise more features than they can deliver. The technical challenges could be quite large and could also lead to very high prices for technologies that might not improve the profit of the manufacturing plant. Another barrier can be incompetent decisions made from the employees and managers when it comes to implementing the new technologies. Furthermore, lack of development of machine learning reduces the scope at which machines can be implemented in our day-to-day activities, as well as manufacturing processes. We can conclude that IoT will have a very important impact in every aspect of the manufacturing industry. It will change the way people manage inventory and demand, control maintenance and repair of machines, improve the quality of control process, increase workplace safety, and improve overall efficiency in a manufacturing plant. IoT is going to revolutionize the world of manufacturing by bringing efficiencies in all of these domains, which will lead to better output, less waste, and lower costs. Even though implementing these changes now is costly and difficult, in the long run they will help cut down on costs and improve productivity. Companies that start thinking about how to use technology in their manufacturing plants by using the power of networks will have a competitive edge.